Hey, also, this is 5C. And this deals with statistical tables and graphs. So let me move that up just a little. All right, so statistical tables and graphs. All right, so first we're going to look at what we call data types and binning. All right, so here we go, a few definitions. So the first is what we call qualitative data. So qualitative data consists of values that can be placed into non-numerical categories. So they're looking at things like your sex, colors, things like that, what we call qualitative. Then you got what we call quantitative. Quantitative data represents counts or measurements. So that could be like test grades, height. Those are different things that are measurements. All right, so we're going to look at a few examples here. We're going to classify as qualitative or quantitative. Oh, that had a T right there. Quantitative. Woo, okay. So A, brand names of shoes. In a consumer survey. So we want to know if this is qualitative or quantitative. So brand names of shoes like Nike, Reebok, those are non-numerical. So since they don't have any type of measurements or account, we would consider this qualitative. So let's see what B has. B has the heights of students. Heights of students is a type of measurement. So since that's a type of measurement, we're going to call that one quantitative. Okay, y'all, so here's a tricky one. So here's a tricky one. Hey, I'm in class. Okay, this one is audience ratings on a scale of 1 to 5. Where 5 means excellent. So this is a tricky one. Although you see numbers here, these numbers are not what we consider measurements. It's just a representation on a scale. So these are what we would call subjective. So this one is actually qualitative. All right, y'all. So if it deals with measurements, quantitative. If it's just a label, such as the shoe brands, movie ratings, we're going to go qualitative on those, okay? So now we're going to get into frequency tables. So I'm going to turn, if y'all need me to go back, I will. All righty, so frequency tables. So a frequency table has 2 columns. So it's going to have 2 columns. The first column lists all the categories. Of our data. The second column lists the frequency of each. Of each category. Which is the number of data values in the category. So basically, we got our 2 columns. The first one lists those data values in the category. Like if I was looking at grades, I would break my categories into A, B, C, D, and F. Second column basically tells me how many times did that category occur. So how many A's did I have? How many B's did I have? And so on, okay? All right, so what we got now is relative frequency. And we'll be making a frequency table up in a second. So relative frequency of any category is the fraction or percentage of the data that fall in that category. To find the relative frequency, we use the formula. So here we go, relative frequency. It's going to equal the frequency in that category divided by the total frequency. So like if I was looking at the relative frequency of A's in my class, I would take all the A's that I had and divide that by the total amount of grades that was added together. So I would add my A, B, C, D's, and F's all together to get the total frequency. And then we got the cumulative frequency. And when you see that word cumulative, it sort of means things that are sort of adding up or totaling. So this cumulative frequency of any category is the number of data values in that category hang on, I'm trying to let one in real quick. All right. In that category and all preceding categories. So that column is just going to be a sum of each category being added as you go down the categories, okay? So we're about to make one of these up, so I'll get to show y'all more hands-on with what we got going on. So if y'all are ready, I'm going to another sheet. I'm going to turn this over because my paper's starting to curl on me. So this is an example. So we consider the following 20 scores. And this is from a 100-point exam. So we got a 76, 80, 78, 76, 94, 75, 98, 77, 84, 88, 81. Can y'all tell? Let me write that again. 81, 72, 91, 72, 74, 86, 79, 88, 72, and 75. So let me make sure I got 20. 1, 2, 3, 4. All right, so that's my 20 scores. So we're going to make our frequency table. So our first column is going to be the scores. Second column will be frequency. Third column will be our relative frequency. And then the last column will be our cumulative frequency. Now we're going to break our scores into categories. So my first one will be any scores from 95 to 99. And then I'll have scores from 90 to 94, 85 to 89, 80 to 84, 75 to 79, what's next? 70 to 74, And then at the bottom will be our total. So we'll figure the frequency of each of these categories, and then we're going to find our relative frequency and then our cumulative frequency. So first of all, we need to count all scores that were between 95 and 99. So let's go through. So I got a 98. So y'all, one score was between 95 and 99, and that was my 98 there. So then I need all scores between 90 and 94. So let's go through there. There's 1. 91 fits. So I had 2 scores between 90 and 94. Right, I'm looking for 85 to 89. So let's see. I got 88, that's 1. 86 is 2. 88 is 3. So I got 3 scores between 85 and 89. All right, next is 80 to 84. So I got 80, 84, 81. So it looks like 3 of those. All right, 75 to 79. I got 76, 78, 76, 75. Ooh, that's 77. That's 5 of them. Let's see, 79 and 75. So it looks like I had 7 scores in between 75 and 79. And then 70 to 74, I have, let's see, 72, 72, 74, 72. So I had 4 of those. So let's add that up and see how many. That should equal 20 because that's how many scores we had. So 1 plus 2 is 3, plus 3 is 6, plus 3 is 9, plus 7 is 16, plus 4. So that gave me a total of 20 scores. So now here's where you're going to want to use your calculator because it wants the relative frequency. So remember, we said the relative frequency was how many times it occurred in that category divided by the total. So I'm going to take 1 and divide by 20, and that's going to give me the relative frequency. So let's see, 1 divided by 20 is going to equal 0.05. So here's how I got that. 1 divided by 20, which equals 0.05, which is equal to 5%. So if they want you to turn that into percent, remember, move that decimal right twice and add the percent. So next we got 2 divided by 20. So this row I'm going to do 2 divided by 20. So 2 divided by 20 is going to give me a 0.1. So remember, move it right twice. That will give you a 10%. All right, next, the next 2 are going to be pretty much the same. So let's see, 3 divided by 20. So this is going to be 3 divided by 20. And this one's also doing 3 divided by 20. That gave me 0.15. So I know both of these will be 0.15. Turning those into percent, move that decimal right twice, and that'll be 15% for each of those. All right, next we got 7 divided by 20 to figure out this one. So y'all, here we go. 7 divided by 20 is 0.35. Turning that into a percent, moving that twice to the right, you get 35%. All right, let's see, 4 divided by 20. That's going to be a 0.20 or a 0.2. Turning that into a percent, move it right twice, and that's going to give you 20%. So here's the thing. If we did this correctly, all these percents have to add up to 1. I mean, all the decimals have to add up to 1. All the percents have to add up to 100. So let's see if we're good. 0.05 plus 0.1 plus 0.15 plus 0.15 plus 0.35 plus 0.2 equals 1. So this row added up to 1 like we needed. So let's see if this adds up to 100%. So I got 5 plus 10 plus 15 plus 15 plus my 35 plus 20. Add them all together and we get 100%. So that's a quick way that you can check and see if you've got that relative frequency down, is because it's got to add up to 1, and then these percents got to add up to 100. So all 20 of them make 100%. So y'all, the cumulative frequency. So the cumulative frequency counts that category's frequency plus any prior categories. So since this is the first category, the first cumulative frequency would be the 1. For the second row, this category had 2, but remember, you got to add the prior row's frequency. So the cumulative frequency would be the 2 plus 1 would be 3. So y'all, I'm gonna let y'all take a shot at this. What's the next cumulative frequency going to be? So y'all can either talk or text or chat, whatever we got.
6.
Oh, I heard it. That was a 6. Good job. Because he took this category and added all the priors.
Mm-hmm.
Right, that means next will be
9.
All right, keep it going.
16.
And then
20.
20. Now here's the thing. When you're done, this cumulative frequency better equal how many you had total. So the last cumulative frequency was 20. It equals 20 that I had total. So we know that's another check that we did good on that.
Okay.
So y'all, questions on that? You know, it's not that bad. The tricky part is adding all the categories and seeing what frequency happens, okay? And then all I did was take each frequency and divide it by my total to get these percents and decimals. All right, y'all, so let's go to the next one. I'm gonna do charts. So this is bar and pie charts. So the frequency was the major thing we're looking at as far as math. The rest of this is just going over different kinds of charts and graphs. So a bar chart shows each category with a bar whose length corresponds to its frequency or relative frequency. So they could put how many times it occurs, which is its frequency, or they could figure out the relative frequency, which would be in the decimal forms, okay? Or in the percents. So now and I'll show you some pictures of these in a second. And then the next one was your pie chart. And pie charts are used primarily for relative frequencies. Because the total pi must always represent the total relative frequency of 100%. So what they're saying, if you add all these pi pieces together, you got to get 100% on that total pi. And then remember, the size of each wedge is proportional to the relative frequency of the category it presents. Okay, so the size of them pieces of that pie are going to be proportional to how much it's really happening on its relative frequency. So if I had a half of a pie colored in with one of my categories, then that would be 50% of that pie, okay? So let me show you some pictures of different charts here. So let me go to a new share. So y'all should be seeing a bar and pie charts now. So over here on the bar charts, notice on the bottom represents the categories, which are my grades, A, B, C, D, and F. Now, over here on the left side, they got it in frequencies based on how many times they occur. On the right side, they broke it down into the relative frequency, which was those percent representations. So if you notice, for A's, I had a total of 4 A's. In the A's, that would have been, looks like 16% as far as the relative frequency goes. So 16% of my students made an A. Then I go to the B's. The B's come up, and the height of that is equal to the 7. So I had 7 B's, which looks like 28%. So notice, next we had C's at 9, which was 36%. My D's, that looks like it's up to the 3, which is 12%. And then my F's, I had 2, which would have been 8%. So notice, the biggest category was C. We had 9, which was 36%. So if you go over here on the pie, the pink shaded part is the biggest piece, which represents those C's, and they're showing you that that is 36%. My next biggest piece was the B's, which is the sort of bluish looking, and they're writing it's 28%. Let's see, next biggest category is my A's at 16%, the green. I had D was next at 12%. And then finally my F's at 8%. So those pie pieces are proportional to how many times they occurred. So what I would have done to make my pie, since I had 25 total frequencies, I'd have divided my pie into 25 pieces. And then for the B's, I would have colored in 7 of them 25. And then so on. My C's, I would have colored in 9. Okay. All right, y'all. So back to the notes. So let's look at important labels for your graphs. So when you're making a graph for somebody, these are some important things you want to have on there. You want to have a title or caption. And that explains what is being shown. And then if possible, list the source of your data. All right, you need a vertical scale. And title. So remember, vertical scale goes up and down. That's what y'all are familiar with calling the y-axis a lot of times. So you should have numbers that clearly indicate the scale. And they should line up with the tick marks. So numbers should line up with the tick marks. So on that graph I was showing you earlier, the vertical scale would have been the frequencies of those A, B, C's, and D's, okay? And then label what that data is. And that's what we mean by the title part. So we was looking at frequencies, so that would have been the title for that scale, okay? You want a horizontal scale in title. So horizontal is left to right, which we would a lot of times call the x-axis. So that's where you list the categories. So list the categories. So list the categories along the horizontal. Tick marks are not needed. Right, because we're just listing data here like A, B, C, D's, and F's. And then, like we said, a title that tells what the categories are. Grades, so Walgo, it would have been grades on the exam, okay? And then the last thing you might need is a legend. You would use a legend if multiple data sets are displayed on a single graph. So you just want to have a key to represent. So if I was looking at, say, boys and girls on my test scores, I might have a legend that showed that the boy scores were the blue columns and the girl scores might have been the pink columns. And just let them know which category was going with which sex on that test, okay? All right, y'all, I'm gonna give y'all a second to write that. All right, y'all, so now we're just gonna look at a few types of charts again. So first, we're gonna look at a histogram. So a histogram is a bar graph for quantitative data categories. The bars have a natural order and the bar widths have a specific meaning. So that's a histogram. Then we got a line chart. So a line chart shows the data value for each category as a dot. And the dots are connected with lines. So for each dot, the horizontal position is the center of the bin it represents, and the vertical position is the data value for the bin. So for each dot, the horizontal position is the center of the bin. It represents and the vertical position is the data value for the bin. All right, and then the third one, and then I'll show you pictures of these also. This is a time series graph. So this is a line chart or histogram. In which the horizontal axis represents time. So this one shows you how something's changing over time. It can be hours, years, minutes, days. It don't matter as long as it's some form of time. So I'm going to show you a picture of some of those real quick. So I'm going to let y'all write that real quick while I pull this up. All right, y'all, so I'm going to go to a new share. So here's a histogram and a line chart. So the histogram, notice you got your data categories, which are scores. And then my vertical axis is the frequency. And then notice the tallness or the width of these columns has a meaning because the height corresponds to the frequency of how many times they happen. On the right, you got a line chart. So notice you show the data values for each of the categories. So in between 70 and 75, that's what they're talking about in between in the category. So my scores from 70 to 75, I would go up to the dot, and the height of that dot is is equal to the 4. So that's telling me that I had 4 scores between 70 and 75. Between 75 and 80, looks like I had 7 scores. So it looks like they're using the same chart I had a while ago, because I remember having 2 equal right here. So my 80 to 85, 85 to 90, both of them categories had 3 each, and then so on. So y'all, that's your histogram and line chart. Now remember, I got the next one's going to be this time series chart. So notice down here on time, their time is the years. So they started up here at 1960 and they're ending at 2012. So this is telling you what's happening with, what are we looking at? Homicide rates in the United States. Now their scale is homicides per 100,000 people. So they took the total population divided by the number of homicides they had, and then they applied it to every 100,000. So when you look at this number over here, this 4 really means per 100,000 people, okay? So let's see. So like 1962, it's right about, it's hard to tell. Close to 5, but not quite there. So it looks like my highest homicides happened on this one. And if I was to go straight down, looks like 1980 was a bad year, because that's my highest peak. So it looks like homicides were going down over time all the way up into 2012. So this just sort of shows you what's happening to a category over time. So they're not too bad, y'all. And that's the main thing we was doing in this section, was just learning how to make a frequency table and then the different types of graphs. So I'm going to stop that share. So I'm going to do some of the problems like you're going to see on homework. Especially the one about making the frequency table. So yeah, most of these are going to be what do you call it, multiple choice type answers. But I wanted to at least show y'all another frequency table. So let me go back to the share. All right, so this is an example like you'll see on the homework. Looks like number 5. So a professor recorded the following grades in one of his courses. So let's see, I had A, and then I had 1, 2, 3, 4, 5, 6 B's. Eight C's. 3, 4, 5, 6, 7, 8. I had 4 D's. And then 1 F. So professor had these grades in one of their classes. So over here, they're breaking the categories into grades. Then we'll put our frequency, our relative frequency. So just like we did a while ago. And then our cumulative frequency. Now the relative frequency, they're going to want all these in percents. So they're putting percents by each of these. So it looks like I'm going to have 5 categories because I got my A's, my B's, my C's, my D's, and my F's. And then down here, we'll put our totals. So we want to count how many times each grade happened. So 1, 2, 3, 4, 5 A's. Frequency of 5. B's, I had 1, 2, 3, 4, 5, 6. So I didn't mind this one because they had everything listed in order for us. 1, 2, 3, 4, 5, 6, 7, 8 C's. 1, 2, 3, 4 D's. And then the 1 F. So let's see what we got. That's 11, 19, 23, 24. So we got 24 grades in this class. That means to find the frequencies, relative frequency, we'll take each of these frequencies and divide by 24. So we got 5. So 5 divided by 24 is 0.208. So I'm going to move this right twice to make a percent. So I'm going to make this a 20.8. So it says round to the nearest 10th as needed. All right, next is 6 divided by 24, which gives me 25%. Next we have 8 divided by 24, 0.333, so I'll make that a 33.3. All right, y'all, next we got what? 4 divided by 24. 0.1666, so I'm going to move that twice. So I'm going to make that a 16.7. Because I got a 6 behind the 6, so that's going to round up to a 7. And then we got 1 divided by 24, so 0.041. So I'm going to make that a 4.2. So I'm rounding that 1 into a 2 because of that 6 behind it. So if you add all those up, they should give me 100%. And bam, there we got 100%. So now we're going to do the cumulative frequencies. So hopefully y'all got that part down. So the first cumulative frequency is the frequency of this category, which would be my 5. Whoops, my hand gets sticky. All right, next we got 6. 6 plus 5 made this one 11. Next is 8. 8 and 11 give me 19. And remember, when we're done, this better equal 24, right? All right, so what's next? 19 and 4, 23. And then my final category, 1 plus the 23 ahead, makes that a total of 24. So on this one, they'll have you fill in for all these frequencies, all the relative frequencies, all the cumulative frequencies, and then they want you to add the column up for the total of 24 here, and add that column up for 24 on that cumulative frequency. All righty, let me see if I'm trying to see if I got anything else I want to hit y'all with. Most of the other ones are yeah, I definitely got one more. Y'all got that wrote? Well, that's sort of hard to see. I'm going to try to zoom that in a little. So here they got states A, B, C, D, and E. And the populations to the right, 38.1, 32, 25, 23, and 14. So these were just different bar graphs, and they wanted you to pick which one represents this data. So notice my largest state is A, and they look like they're descending or going down as I go through the states. So this one has E first and saying it's the largest, but E is actually the smallest one. So we know it's not going to be that one. Over here, they got them in the right order, but A, they're showing to be the smallest one when A is the largest one. So we know it can't be that one. Let's see what they're doing here. So they're in reverse order. So no, we want them to be in the right order because it's telling us with the bars in descending order. Those are in ascending order. This one is sort of right, but it's not in the right order we wanted. So you don't want to pick that one. All right, D has them in the right order. A is the largest, E is the smallest, and these are in descending order because they go from large to small. So we know D is right. Here, they're not in descending order. They're just in whatever order they put them in. And then this one's not in descending order. So we got to take that one out. So the only two that were really in descending order were A and D. But the only one that had my labels right on the bottom was D because it went from A being the largest to E being my smallest. So y'all, that's sort of what you're going to do on homework. Just look at these little charts and see which one's right. They're going to ask you about qualitative and quantitative data. Things about your frequency. So quantitative or quantitative? Flavors of ice cream. Oh, let me move that back up. Y'all can't see that. So flavors of ice cream, qualitative or quantitative? So the thing you got to remember, to be quantitative, you got to be able to have things that are measurements. Well, flavors are just labels. So since flavors are just labels, this is quantitative. And then another example, annual salaries. Of NBA players. So now you are looking at something that you can measure. You can measure the amount of their salaries. So since we're dealing with numbers that are measurements, this one would actually be quantitative. Okay. So you're going to get questions like that. You're going to make a frequency chart or two, and then you're going to have a few questions on my charts, okay? So y'all, it's not too bad. So let's see. All right, so I'm at the point where y'all got any questions on this? And y'all probably played with charts before. So I don't see no questions. And y'all, I just want y'all to know I put in midterm grades for what I had in Math Lab at the moment. So if you want to check those out, you can. All your teachers have to have your midterm grades in by Wednesday night. That gives you an idea of how you're doing in our classes and everything. And then reminding y'all to register for your spring classes. Some of those classes are starting to fill up. So if you want to get your schedule to be ideal, get on there and get them classes, okay? Also, I'm going to stop this recording